When you run LLM inference on production, you might have faced a situation where you have to decide to run whether that LLM inference on your own rented GPU or just call the serverless API and pay per token. Everyone got an opinion, but nobody shows the actual number. So in this video, I ran both model on the rented GPU and on the serverless inference. And I put the stopwatch and recorded the part which nobody shows you. Same model on both sides. Let's see what happens. So I have AMD GPU Droplet with me, and all the necessary drivers are already installed in this to run and serve any model. When you create a GPU Droplet, you will get an option to select that, pre-install all the necessary drivers. And this will be the stage just before you do the scale up or deploy of your Droplet. So now let's do the cold start. Before we do the cold start, I just want to give a quick info on what cold start means. So cold start is the gap between the first process launched to the first token serve. I have already consoled in my GPU Droplet. Now what we will do is run our GPT-OS 120B model and we will start the stopwatch. It will take some time for it to get load. Great. So now our model is serving. And just to be clear, what that 60-second mean is that it didn't download the model from the Hugging Face because model weights were already on the disk. In the screenshot, you can see how much time it took to load the model weights into the disk, compile time, and the warm-up time. Because in the ideal production case, you will not re-download the 60 gigabytes of model every time. 60 seconds is the actual time you will pay every time whenever you do the scale up of your droplet. Once the machine is warm, it's different. Now we need to check and do the benchmarking how much time it actually takes to serve the first token. How many tokens it can actually serve in 1 second. So for that, I have already wrote a script, and what we will do is we will just run this particular script by running this command. And once we run this command, we will see that it took around 322 milliseconds for the first token to serve and around 152 tokens per second. And we can easily see that it is pretty steady for the 20 runs that we did. So the trade-off for self-hosted GPU is pretty clear. It's warm, it's fast, and it is yours. But every cold start costs you around 60 to 61 seconds. And you pay for it. You pay for GPU which is not getting utilized and used. Now we will do the same test on serverless inference. And to do that, we need to create a model access key. You can go ahead and create a model access key from here. And I already have a model access key for me. Once we have the model access key, we can go ahead and hit the OpenAI compatible base URL. And I haven't touched the endpoint for a while. So let's do it. Okay, so you can see here that I'm making a basic curl request to this particular URL. I have already export my key as DOK, and that's it. And we will do the hit. And once I hit the base URL, you can see that it took barely few seconds and we literally got the response. There was no cold start. It was because model was already up and running, and that's why there was no spin up. But why? Serverless didn't delete the cold start. It actually absorbed it. DigitalOcean pools GPU capacity across customers. So it keeps my model warm, up and running without any effort. The trade-off is we are not paying per hour, we are paying per token. Also, to be fair, serverless isn't immune always. You might face cold start sometime. And to fix that case, you can send warm-up pings asynchronously. For my case, I didn't need it because it was already up and running. Now, I did the same TTFT benchmarking with serverless as well. It took around 546 milliseconds to 1.3 seconds for the first 4 token to come. You can see that there is extra latency in our request compared to our own hosted GPU. It is because the request went through all over the internet to the DO network, and same in reverse, which was not the case with the our own hosted GPU because we were doing the benchmarking within the droplet itself, and that's why there was no network latency extra added. So the extra latency you see is just the gap of network. This extra latency doesn't mean that our serverless model is slower. When a serverless inference is cheaper than owning your own GPU? Well, it's just a myth. GPU's flat cost is around $2 per hour for MI300X AMD GPU, and for serverless inference it's like 10 cents for a million tokens in and 70 cents for million tokens out. And to find that which one will be cheaper, we need to do a benchmarking where we need to figure out at what point both the serverless and the owning your own GPU cost same. And this benchmarking we did between the serverless and the MI300X AMD GPU. So what is crossover in our benchmarking? Crossover is just a request volume at which serverless and the owning your own GPU will cost same. Now in the screenshot you can see that on the short responses we got around 18 requests per second. At this point serverless and owning your own GPU will cost you same, and for the medium response type we got around 3 requests per second, and for the long response type we got 1 request per second. So in simple terms, if your application generates short and quick responses, then serverless is cheaper until unless you are doing dozens of those requests in a second. Otherwise, if it generates dozens of long requests, then owning your GPU will pay off. So which one you should pick? Let me tell you, for most of the teams, serverless makes sense if you have bursty traffics or quite stretches where nobody is using it, or it's a dev tool you have, or some internal thing where you are not waiting for first response. Then serverless will make more sense. Run your own GPU when your traffic is heavy and constant, where you have a latency which you can't miss. At that point, you are using GPU enough that paying per hour beats paying per token. You keep it warm so that cold start is not the problem anymore. Serverless is not worse, but it's just not the right fit in this case. And if you are not sure which one you should pick, start with serverless. Keep your eye on the token spent, and the moment you see that math flips, go and switch to GPU. Don't buy a GPU for the problem you don't have. All of the benchmarking we did in this video are reproducible. Go check out the comment. I have published a detailed blog on how you can do it too, and run those benchmarking on your own GPU and serverless. If you have measured cold start by your own, I would love to know that. Feel free to drop in the comment.